Okay, first thing I want to go over is probably the biggest thing, which is taking a random point and reflecting it over a diagonal line. And I'm making this up off the top of my head. I got coordinate B is -2, 3. And I want to reflect it through the line y equals 2x minus 4. Okay? 2x minus 4. All right. So I know this is going to involve, actually, I should probably graph it. It's just to get a visual. Grid. All right, so I have -2, +3 for point B. Let me graph the line. I'm going to reflect over 1, 2, 3, 4, up 2 over 1, up 2 over 1. So I'm going to take point B and reflect it through this line right here. All righty? All right, so what I need first is, because I'm going to use my calculator on this, I know I need the intersection of two lines, one line being that line of reflection, 2x minus 4. The other line where I need to figure out where it intersects 2x minus 4 is going to be the equation of B prime. Okay, B prime, wherever B prime ends up being, I'm just guessing, like say it'll be right here, B prime. I need to know where these two intersect. So in my calculator right now, again, in Y1, I have 2x minus 4. Now I need to type in the equation of B prime. How do I get there? All right, let's talk. How do I get to the equation of B prime? Number one, we talk slope. All right, we know that my line of reflection and B prime are perpendicular to each other. So the slope of 2x minus 4 is 2. I take the negative reciprocal, -1/2. So that's going to be the slope of B prime. Number two, let's find the y-intercept, the B value. Because remember, when you type it in your calculator, it's got to look like y equals mx plus b for you to graph on the calculator. And to find the B value, I'm going to need an x, y point to plug in. I'm going to need an x and a y point to plug in, but where do I get that? Remember, that is a point on B prime. I need to plug in some point that I know that's on B prime. Do I know a point on B prime?
You know B.
I know point B. So I'm going to take -2, 3. Ready, everyone? Plug 3 in for the y. M, we already found out in the previous part, was -1/2. X is -2. Plug in for B. So again, in for y and x, we need to plug in a point on B prime, which I was already given. All right, now solve it for B. What's that, 1? Move the 1 over. My y-intercept is 2. So the equation of B prime, y equals -1/2 x plus 2. All right, all good? That's what I'm going to plug in now to y2 in my calculator. So -1/2 x, forgot already, plus 2. Okay, graph. There are my two graphs. They look perpendicular on my screen. Now what I need to know is, where do they intersect? Because that's going to be the midpoint that I need. Where do they intersect? Slowly, very slowly again. Second trace, which is on the top row of your calculator. Second trace. Choice 5, intersect. Make sure I move using my right and left arrow keys, move that spider as close as I can get to the point of intersection. Enter 3 times, or if you want to remember, first curve enter, second curve enter, and then guess your final enter. And there is my point of intersection. Not very pretty, but I'm going to have to deal with it. 2.4.8. And I've already corrected the kids who took it today. A lot of people just think that's our final answer. That's not B prime. Where the two lines intersect is not B prime. That is the midpoint of B prime. So what I'm going to do now is, all right, I'm going to take point B, which was -2, 3. I'm going to take that midpoint, which is halfway in between, 2.4, 0.8, use it to find B prime now. So now I'm going to go, all right, -2 to 2.4. -2 to 2.4, that is an increase to the right of 4.4. Do it again, because remember, you're right in the middle. So let's do it again to get to B prime. So increase the X by 4.4, 6.8 for the X coordinate. And then let's do the same thing for the Y's now. 3 to 0.8. Wow, that's a big decrease, huh? That's a decrease of 2.2. No, it's not. Yeah, it is. I'm going down 2.2 units. So let's go down 2.2 units again. I have no shame. We're 0.8 minus 2.2. -0.14. Okay. And I just, give it a little check here just on my graph, see if I'm in the ballpark. 1, 2, 3, 4, 5, 6.8, -1, a little more. Yeah, pretty good. I'd say if I folded my screen right over that line, B and B prime would match up. All right, so expect one of those tomorrow. That's the big one. All right, all other things to expect tomorrow. A lot of rotations of 90 and 270. Let's make sure we know our rules for a reflection through y equals x and a reflection. Actually, why don't I just pick coordinates? I think that's easier. So here you go. I got 6, -2. I want to reflect it through the line y equals x. What am I doing with 6, -2?
Flipping them?
Yep, just switch them. Don't change the signs. So the image would be -2, +6. And also, let me take that same point, 6, -2. What's your rule if I ask you to reflect it through y equals -x? Y equals -x. Now, what am I looking at there?
You switch them and negate both?
Correct. So I'm going to switch them and negate them, or if you'd rather think of it this way, switch them and multiply by -1. So -6, +2 would be the image there. Again, a lot of rotations of 90, 270. Make sure either you know the rules or if you're going to turn your paper, how that works. Notation, translation notation. Because I am going to ask a couple translation questions and ask that you leave it in a certain notation. So the first notation is function notation, which says x comma y goes to, and then this could be whatever your rule is, x plus 2, y minus 1. Okay, there's function notation. Then you also have vector notation, which just basically says inside here, you're going to tell me what you're doing. So 2 to the right, down 1. And also, I know I went over this in class yesterday, but just to remind you, because it's been a couple hours, Make sure you can reflect over something like x equals 2. Reflect over something like y equals negative 3. X equals a number is your vertical line. Y equals a number is your horizontal line. Okay, so just make sure we're aware of x equals and y equals. And that is pretty much all I have to give you guys. And now, anything you want to ask of me now?
So for the last thing you were talking about, like r x equals 2,
Yep.
if there an x after the 2, would it then turn into the first problem that we did?
I would never do x. I would always be y equals first, Sarah, because if I did x equals 2x, that's not a line at all.
Oh, yeah, sorry. But like if we did y equals negative 3 and then there was x, but no like y-intercept, no b, then it would be one of the first problems?
Correct, yes. Yep. The only diagonal lines that you guys should know the rules for are y equals x and y equals negative x. Any other version of y equals something else, it's got to be that first type that I just went over where you use y1 and y2 on your graphing calculator. Other?
Hi.
Hi, how are you?
I'm totally new with you.
It's all right.
I'm Sarah Chandler. I just have
Yes.
an offer and a question. As football, I do sports photography.
Okay.
I shot pictures for Burnt Hills because my kids play for Burnt Hills. I have so many of the boys in public speaking and different things. I don't know if I can be on the sidelines or if you have someone taking pictures.
We do.
Okay.
Yeah, we do currently have a photographer.
Okay, good. I just wanted to make sure.
Yeah, we do.
Because I wasn't sure if you did last year. I didn't remember seeing someone, so.
Yeah, we do.
Okay.
And I don't know if they're going to be on the sidelines or not. So,
Well, that was the other thing.
Yeah.
I mean, for me, it's just a way to
Yeah.
go watch some football too.
No, and don't have to worry. Yeah.
Yeah.
But,
All right. Well, good enough.
But I'll keep you in mind though, definitely,
Yeah, it's fine.
because
My kids are now in college.
we
so.
just keep at. Well, this one is his kids have been out of school for years too.
Oh, he's still doing it.
Yeah.
Okay, good.
Yeah.
Yeah.
So
I have no one to and I mean, with this year and everything, but my camera's just collecting dust at this point. I'm kind of sad about it, but. All right.
no,
well,
but
good
thank
luck.
you, thank you,
Yeah.
thank you very much. Take care. All right, guys. Other questions that you guys have?
Can you go over reflecting something onto itself?
Yep, you got it. So I need, I have to, without a doubt, I need to give you guys a figure, a regular figure. It's got to be regular. So let me take the hexagon here. So this is a regular hexagon. All sides and all angles are equal. So how many degrees would it take to rotate it onto itself? Meaning what you guys see on the screen right now, I got to see that same hexagon back. Not one that's tilted to the right or the left. I got to see that same exact hexagon back that looks in that same position. So what I need to determine is how many degrees does it take, for instance, to go from C to B? Because if I turn this hexagon from C to B, looks the same as the one I started with. All right, so that's what I need to figure out right now is as I go from B to C, C to B, how many degrees is that? So we talked, I got to pretend to myself that I turn this all the way around, vertice B to vertice B. And we know when I go all the way around, that's 360 degrees, no matter what the figure is. I turn anything all the way around, it's 360. But the key is, depending on the figure, how many rotations does it take to get all the way around? So C to B, B to A, there's 2, 3, 4, 5, 6 rotations. And you guys, yes, it does match the number of sides. It always will. So I take 360 divided by 6, and that tells me I can go 60 degrees to get this figure onto itself or back to the original diagram that I have up here now. So every time I go 60 degrees, I'm going to see the same exact hexagon back in the same exact position. Now, let's say 60 is not an option. All right, well, I keep going 60. Is 120 an option? Because that would still work. Is 180 an option? Because that'll still work. How about 240? That'll still work. 300. Any multiple of 60 is going to work to get that hexagon onto itself. So I don't, if you see a question like this tomorrow and 60 is not a choice, you can't freak out because there's other choices that still would put it onto itself. Other questions, concerns? Again, big ones at the end, just like I did at the beginning of the review here. You'll have graph paper at the end of your quiz to use, so you don't have to worry about bringing your own. And it'll be attached into formative if you're taking it on formative.
In our packet, we had function notation, vector notation,
Yep.
and then another one.
Yep.
What's the old?
We don't have a name for it, so that's why we just called it other. All you need to, Sarah, just with that notation, all you got to be able to recognize it. Like if I put, if I have one of these questions tomorrow and I say, all right, point P is 6, 4, perform this transformation, and I just give you the capital T and I say 0, -3, you're just going to have to, hey, that's notation for a translation. So this is how I'm going to perform it. Yeah, I wouldn't ask you to write it in the other notation. I'll either have the vector or function for you to leave your answer tomorrow. Anything else, guys? Whew. Nothing else? Feel good? Okay, basically, I just went right through the quiz with you there and gave you everything I needed to highlight. So make sure you just pay a little bit more detail to when you're getting ready for tomorrow. All right. All right, guys. Thanks. I'll see you tomorrow. Behave like usual.
Thank you.
Yep. Make sure you look over this stuff again. Thanks, guys.
Thank you.
Bye, guys.
Bye.
Take care.